Hi everybody. So again with me Rozaina Ismail from UiTM Shah Alam. Okay, so now our lesson is on Eurocode 0, 1 and 2, which is focusing on limit state and also design action. So based on Eurocode 1990 principle of limit state design, we do have ultimate limit states in clause 3.3, serviceability limit state in clause 3.4, limit state design in clause 3.5. So in section 3, which is principle of limit state design, which refers to clause 3.3, the limit state concern on the safety of people and the safety of the structure, which shall be classified as ultimate limit states. Right? And we move on, serviceability limit state in clause 3.4 in Eurocode. This limit state is actually stated concerned on the functioning of the structure or structural member under normal use with comfort of people. Okay, so this shall be made between reversible and irreversible serviceability limit states. Alright, now let's move to the limit state design. As I mentioned before, we do have two types. The first one is ultimate limit state, and then the second one is the serviceability limit state. Alright? So basically, ultimate limit state is actually when the structure or some part of it is unsafe of its intended purpose. For example, for instance, compressive strength, shear or flexible, flexure, failure or instability leading to partial or total collapse. These present a direct risk to the safety of individuals. Move to serviceability limit state, which condition, for example, deflection, vibration or cracking, which occur to an extent causing discomfort to the occupants, but this SLS not resulting in a direct risk to the safety of people, but the structure unsuitable for its intended purpose. Now we move to ultimate limit state. We do have 6 ULS here, which is EQU, stand for equilibrium, STR for structural, geotechnical, fatigue, uplift, and hydraulic heave. So this 3 is actually refers to resistance limit states. Another 3 is referring to stability limit state, and finally these 2 based on Eurocode 1997, which is more on the geotechnical aspect. Right? So now let's move to the section 4, basic variables. Classification of section. Action is actually shall be classified by their variation in time as follows. It has permanent action, and so-called G, for example, safe weight of structure, fixed equipment, and road surfacing, and indirect actions caused by shrinkage and uneven settlements. Next, variable action, stated as Q, capital Q. For example, imposed load on building floor, beams and roofs, wind action or snow loads. And finally, accidental action, A, for example, explosion, impact from vehicle. As you can see here, this table shows the action on structure. So basically, the action is the Eurocode terminology for load. Eurocode define an action as a set of forces. So the action may be permanent, safe weight or structure, and also variable Q. So in general, The design value of action is obtained by multiplying the representative value F, okay, by the appropriate partial safety factor for action. So this is the equations, okay. And then this table, the first table up here, is actually shows the recommended values of partial safety factor for permanent, okay, for imposed load, okay, and also for wind, okay. And it can be seen that from this table, I can show you again, okay, the maximum value for permanent is 1.35, okay, and the variable load or imposed load has the maximum of 1.5. Therefore, it can be seen that the maximum value for permanent and variable is 1.35 and 1.5. So this is the total design ultimate loads that we are going to use in the design process. So that's all from me. Thank you for watching this video again. Bye.